to the, I think you guys are really waiting for this one. Okay. So, change of variables. So what do we have with change of variables? Most for Math 127, again, there are different places that they have different emphasis. For Math 127, the emphasis, there are two sets of change of variables that we have. One of them is that you decide about U and V, and then you find it. The second one is the spherical and cylindrical. This is the most emphasis that I have for the change of variables. One of those, one of these, or two of those, one of these, or one of those, two of these. I don't know. But it's just like these are the major parts that we're covering in 127. So there's a decide about U and V, and then spherical and cylindrical coordinate. If you're deciding about U and V, again, emphasis is to have it, I say emphasize on linear transformations the most. Emphasis comes with Y or I. Okay, emphasize, so I know it's I. Emphasize on linear. Don't forget the Jacobian, which is absolute value. Well, it's this one, right? If you're finding U and V first, you can possibly do the reciprocal of the of that Jacobian and use it as this. You may or may not need solving for X and Y when you find the U and V. And spherical and cylindrical, don't forget the Jacobian. There is the cylindrical is R, that one is rho sine of phi. Don't forget the that routine. Y equal to for spherical. I wrote it in the wrong place. That's for that one. And Z equal to rho cosine of phi. So don't forget these formulas, cylindrical, cylindrical, you know. I don't think you guys have any problem. And just remember Z equal to Z, and X and Y is like polar coordinates, right? So those are the major things that you don't want to forget. Now let's start with one of these. Let's start with one.
Sheila, there's a question in the chat.
Oh, what's the question? Okay, so the reciprocal thing applies to both linear and nonlinear. The only problem with nonlinear, linear because the other way around is a constant, and when you reciprocal, it's going to be constant. It's a nice one. When you have nonlinear, it would be variables. So you will end up with still X and Y in your Jacobian. So you still have to replace X and Y or simplify or do something with it. It works for both ways. As long as, so the story, the important part of it, and you will see in the future, this doing the function being able to go both ways, transformation and inverse transformation. Having that inverse comes from that Jacobian not being zero. And that's actually an important part of it, because a lot of these surfaces, we know We don't know if we don't solve for a variable. They are implicit surfaces. And then through that knowledge of Jacobian not being zero, we know that around those points, they have inverses. And so that becomes or the function is a nice function, that sort of things. And so that becomes an important part of the mathematics, that Jacobian not being zero, not only in these transformations, but in if you take higher level mathematics, then you will need it, basically. I don't know what, and I don't have any exactly what you can take, depends on your major. You may need some of those higher mathematics courses, basically. Okay, so are you guys ready? I have very little time left, and I have to do at least maybe 2 of these and 2 of the spherical and cylindrical, and then let you guys go. And please practice concepts of, those are going to be the last thing that we cover, but that will be on the exam, but practice curl, gradient, and divergent. That's divergence, and so those are important parts. So let's start with this one. And I'm trying to take this integral. Is this possible to do using simple integrals? Yes. You can divide the region into simple integral and integrate. It's not too badly. But we may ask you to do the change of variable and do this problem, basically. So let's do x and y. And what do I have? I have x plus 2y equal to 6. Let's do it this way. I'm going to eventually get this. Now, okay, this is x plus 2y, and then equal to 6, and x plus 2y equal to the other one. X plus 2y equal to 6, x plus 2y equal to 10, and then we have y equal to 1, y equal to 1, and y equal to 3. So it's this region. Can we divide it into simple regions? Yes, there will be 3 simple, I think. Wait. Yeah, we can divide it into simple region. There's a simple region in the x direction, basically. But I guess question here is trying to build you up to get prepared for when dividing it into simple regions not going to help. Makes sense? So it's a simpler question, but it helps you to get there. And so now I want to do a change of variable in here. So how do I do that? My feeling is this. If I choose that to be U and choose this to be V, then what would this be in terms of U and V? That becomes U plus V, right? And this change of variable makes the region rectangular and nice to work with. So that's what I'm going to do. So my guess is U equal to x plus 2y, V equal to y. Then if I'm computing in that direction, that's the reciprocal of the actual Jacobian, right? And remember, Jacobian the Jacobian, you have to take the absolute value to plug in. That's another thing to remember. And so this Jacobian is U in terms of x is 1, U in terms of y is 2, V in terms of x is 0, V in terms of y is 1, and so it's 1. They do that right? I did that right? So it's 1. So the reciprocal still is 1/1. I have a bad feeling. It's that time of the day that I start malfunctioning. You guys have my back and tell me if I'm doing my computation wrong. No, that's fine. Okay, so I have the one over here. That's the actual Jacobian, and I like it. I like to write it this way. Why? Because then I write. We had G of U and V. I write it as that, right? Or D of A of U and V. And that kind of helps me know that what I say is that this part looks like dy dx times dx, because these two simplify. And so these two, that's my way of memorizing. It has no mathematical background. It's just way of memorizing. So I remember that it's the Jacobian that goes in the integral should look like that. It should be x and y on top, u and v in the bottom. So it simplifies with the whatever simplify means. Again, not very mathematical, but a way to memorize it. And so that's the story. I mean, it's not entirely unmathematical, but how I explain it is unmathematical. That's the thing. So that's what I have in there. And then what do I have? U is going to be between 6 and 10. V is going to be between 1 and 3. And I can set it up, du dv. And this one was supposed to be u plus 1 v times 1. And u goes from 6 to 10. V goes from 1 to 3. And that is a nice integral now. From 1 to 3, u squared divided by 2 plus uv, 6 and 10, dv. And u has to be plugged in. And 100 divided by 2 plus 10v minus 36 divided by 2 plus 6v. Can I stop integrating? I think you guys got the point. And so you can find that. I think it's going to be 80. Are you guys okay? Move to the next page. Now, which ones?